Welcome to Constant Variables, a podcast where we take a non-technical look at building and growing digital products. I'm Tim Bornholt. Let's get nerdy.
Welcome to another episode in our Oofda series, sponsored by the Jen Mahonis Group, where we bring on a technical subject matter expert and have a casual and approachable conversation to make said technical subject more relatable to everyday people.
Hey, Bryson and AJ, welcome to the show.
Hey, Tim. Thanks for having us.
Yeah, great to be here.
Like we were talking about before the show, I consider myself a grandpa when it comes to doing server development, and I don't have a ton of experience in the serverless world. So I'm excited to have the experts on with me today, and I'd love for you both to give me a overview of how you guys got into serverless and what makes you guys the subject matter experts here. And why don't we start with AJ?
Sure. Thanks, Tim. Yeah. My name is AJ Stuyvenberg. Currently, I'm a lead engineer for the serverless team at Datadog. We are a SaaS platform for monitoring observability. You may use our tools to figure out what's going on in your production environments every day. So that is what I'm doing today. I think I got into serverless around, I want to say 2016. At the time, I was working at a startup, but the startup had acquired a few other companies. And we had this amazing ops team, and they were effectively spending weeks of their time working on these kind of new companies that we had acquired and going through, due diligence and compliance and those sorts of things. And what I learned was that I could still be productive in an environment without my operations team necessarily, holding my hand all the time or helping me, scale up new applications. And I found that productivity through, this world of serverless. So what we were doing was trying to deliver a couple of new solutions. I was working at a sports tech startup called Sports Engine in Minneapolis, and we had to deliver a couple of new capabilities that were kind of gluing together a number of different pieces, and we ended up building kind of this event-driven serverless application, and that was kind of my first introduction. And I think what I loved about it was that I could control not only the app layer, but also kind of the infrastructure sort of from one place. And since I was going to be on call for everything, I wanted it to be as managed as possible. And that was really my introduction. And from there, was there for another couple of years, and then moved on to Serverless Inc., the folks that kind of make and publish the serverless framework. Did that for a couple of years, and that's brought me to Datadog and where I am today. Right on.
And how about you, Bryson? What's your story?
All right. So I'm a staff systems development engineer at Jamf Software, or just Jamf now. I've been here for 10 years, and we used to be called Jamf Software. I'm the technical lead on the API platform team. And I'm a little later to the serverless game than AJ. But my story really was that our cloud group used to be called Online Services. And I was brought into that to start updating it to be less centralized and more distributed, and just revamp the code base because it was a very monolithic thing that they threw onto an EC2. And I had all these plans for how I was going to break this up, and I was going to start deploying small Flask applications that had web APIs in front of them instead of relying so heavily on, looping scripting and calling a database for work and things. Like, it was a very traditional automation setup. And reInvent 2018 happened, and I'm just this kid, a 30-year-old kid, but still a kid, sitting in the audience and absolutely starstruck because, AJ can correct me here, but 2018 was the year that AWS leaned really hard into, look at all these things you can do with Lambda.
Yeah,
and I went, oh my God. And I went to every session I could after I got a taste. I got home and I threw away everything I had written for all this work to do with Python Flask applications. And I rewrote it all to use API Gateway and Lambda. And I've never turned back ever since.
Man, all right, you're making me you're giving me FOMO here. So let's increase the let's increase the FOMO. You both work with the Serverless Meetup group, and that's here based out of the Twin Cities. How did that organization come to be?
It was started by Brandon Johnson and Eve Pichelle, who work here in Minneapolis, and brought me on a little after they had started it. But we Serverless MN is a community-oriented meetup group headquartered in Minneapolis, Minnesota. Previously, we were able to have some kind of in-person events, and of course, with COVID, we're mostly remote. For our group, that's been a mixed blessing because we've had the opportunity to have a few people that have more of a larger presence in the industry that probably wouldn't previously have been able to make their way to Minneapolis to talk. And instead, we were able to get a bunch of great speakers. We've been on a bit of a hiatus recently, as I think most folks have a fair amount of Zoom fatigue, but we're really looking forward to getting stuff back going and back in person as soon as we can. Right now, of course, the whole return to office thing is sort of precluded our ability to get office space after hours to meet up. So we're working towards that.
Yeah, I actually had, I think my company, we were set to, I met with Eve it was like January or February of 2020, and we were set to sponsor, like buy pizza and stuff for the March 2020 event for Server. I'm still waiting to sponsor one of those events.
We'll cash in on that. I promise you, Tim, you're on our list for sure. But
good. Yeah. All right. I love it. Well, let's go ahead and break down the word serverless, because I guess for me, being like pedantic and I like to put my thumb in wounds, like, serverless to me seems like it's a misleading term, but maybe I'm
a name.
Yeah. I think that's the current meta in the community is debating, like, serverless is a bad name. What's the better name besides serverless?
So what is it? Like, is there a general consensus of where things are moving, or is everyone just kind of like, well, it's serverless and we don't really care?
AJ and I were talking about this just a little bit the other day, and I think what we hit on was that when you think serverless, it's not about less servers; it's more about capabilities. You're not concerned with what goes on behind the scenes. You're concerned with the capabilities that you're being provided and how you can use them.
Yeah, exactly. The idea is outcomes and not necessarily infrastructure, right? Like it's more of a set of guiding principles that unify a number of managed services that you can link together to achieve like an outcome versus here's like here's your magic serverless box, and if you just buy this box and put it in your rack, you'll have serverless, right? That's kind of the antithesis.
Yeah, like you've got a bunch of tasks and then a bunch of code that sits between you and your business logic today, and the idea of what serverless as a concept is that 90% of that goes away, and you are that much closer to just the business logic and not all the stuff that it takes to get to it.
Yeah, and I think maybe it'd be worth diving in here a little bit, because we sort of answered in like a vague, maybe industry speak manner, Tim, and I'm getting the impression you want a little bit more.
Yeah, I mean, I think I think this podcast is kind of becoming just a one giant analogy machine. So maybe what would be helpful is if you had like a traditional application, maybe explain like what that would be like, and then what it might look like in a serverless world.
Yeah, going back to like the whole thing where I jumped on this bandwagon in the first place. Think of it from that perspective. I was going to build a bunch of automation using a much more traditional stack. It was still going to be web API based, but I would have to provision servers to deploy those Flask applications to. I would then be responsible for the uptime for those, or I would have to ensure that staff in my department was well prepared for maintaining it. There's a whole lot of checkboxes that need to happen in order to make sure that all this stuff I was going to build, deploy, and run was well supported. The switch over from saying I'm not going to deploy a bunch of web apps, and instead I'm going to use API Gateway and I'm going to use Lambda. What happened there is that a lot of those requirements went away because the uptime of the application wasn't dependent upon, is my server healthy, or did the web app crash and needs to be restarted. Those concerns went away. And instead, it was more about focusing on, okay, I have this path and I'm going to hook it up to this code, and this code will go and do this thing. And the overhead for operations greatly went down. and I was able to do more with less time.
And we can generalize Bryson's story just a little bit to something I think a lot of listeners would resonate with. In the onset, in the early days of the internet, all a server is a special computer that's on all the time, right? With a static IP address and a little bit of extra flair. But in those early days, you would have that box under Bryson's desk, and when the server went down, you'd be like, Bryson, kick that box, right? And from there, we're like, you know what? If our business is going to run on this hardware, and our business is inextricably linked to the uptime of this machine, maybe we should put it somewhere safe. So the idea of like, okay, we'll create a server rack, and we'll have redundant power supplies, we'll have redundant internet connections, and at the same time, we were like, well, hard drives fail, right? Hardware fails all the time, and there's all sorts of other issues with software that we won't even get into. So how can we make that more redundant, right? And we started thinking about having more machines spread out in different places, not just physically, but also in terms of like internet connections and where we're going to deploy these things. And we kind of moved to this world of co-locations and data centers. And from there, the cloud, the public cloud as we know it, sort of started to emerge. And the idea was, don't buy the land, don't buy the hardware, just rent it from us at like an hourly rate. And that was a pretty good concept, right? And it still is, right? EC2 and some of the other cloud providers allow you to not worry about the physical security of the building, not worry about the electricity or the internet connection, or even the underlying hard drives, right? You just sort of get to rent a slice of a computer for a certain price. And really, the serverless sort of movement is just like the next iteration of that. It's like, what if we didn't worry about another layer here, which is the networking, the operating system, some of the software parts of the stack. In a similar way, we abstracted away the hardware components. So instead of that world of like, let's manage a one machine, the operations movement in the early aughts was, we should have cattle, not pets, and treat these machines as tools and not pets. So if one dies, we'll just have another one, and ideally they're self-healing and that sort of thing. And serverless technology and the FaaS, or functions as a service technology, is sort of the consequence of that kind of line of thinking.
So if I'm understanding this correctly, then, like with the metaphor of taking your metaphor, I guess, where you have a machine that's running all the time, and if I'm somebody in the business that needs to access information, I just send a request to that machine directly, and then it does something and it gives me back information. In this world where everything's based off of functions, if I'm a user out in the world and I want to go make a request of the system, can you walk through like what actually happens? Like some machine has to accept that request and do something, right?
Yeah, it's a variation of the interview question. What happens when you type a URL into your browser and hit enter, right? So the way that would work in a serverless world is connecting a couple of managed services together. And for Amazon specifically, you'd talk about, as Bryson mentioned, like an API gateway product. There are a couple variants, but broadly fall under the API gateway umbrella. And what that's going to do is, resolve your domain name to, well, they have a domain service, but that will resolve your domain to your AWS account effectively, with a couple of other odds and ends mixed in. And it would allow you to do some basic authorization. And from there, you can integrate into kind of the event system that really makes up the bulk of serverless. So that event can trigger a Lambda function, which is where you could run business logic for that request. For like a front end only application, that request could go and hit an S3 bucket and pull back static assets, or like a React app or a single page app or that sort of thing, depending on what you're doing. That request now could also push a message onto a message bus or a queue and begin processing something asynchronously, something outside of the scope of your request. It could be acknowledged right away like a webhook, and then kick off a broader process. But for the purpose of like, okay, I want to get 4 kilobytes of data, you broadly see that as API gateway request forwarded to a Lambda function. The Lambda function does some business logic, maybe validates like tenancy in like a multi-tenant application, will ensure that you have authorization for this organization's data that you're requesting, right? And then it can go out and hit a data store, maybe DynamoDB, pull that data back, maybe transform format it, and then send it back to the requesting user. So the serverless, methodology is this process of connecting a few managed services in such a way that you don't have to really be on call for any of the underlying hosts. So you don't care about the API gateway servers that are running. You don't care about the servers that are running underneath Lambda, and you don't care about the servers that are underpinning your data store. You're just kind of using these higher level constructs and tying them together.
One question that I've always had with serverless is how things work in terms of like response time. So like I'm thinking if I make a request to a server that I own, I know that the only time that it takes to respond is just how fast the machine is at generating the response and sending it back over the wire. But if things aren't running all the time and they just are living in Lambda functions, like, does it take time for you to spin up those Lambda requests? Like, is there a big difference in time for how quick data gets back to you? Or is it like they're basically always running and they just process as they come in?
They're not always running. This is one of those answers where there's a little bit of it depends at the beginning. With Lambda functions, yes, there is this concept called a cold start, which means that Amazon has the code that you gave them, and it's sitting out there, but they don't keep a copy of it running all the time, ready to take requests. So this idea, in the original definition of serverless from AWS, you only pay for what you use. So until you do something that would trigger your function, that it's just not loaded and it's just sitting there and you're not being charged for it. Once you've done that trigger, then the Lambda service will bring up your code, perform what we call a cold start, where it loads everything into memory, and then it will invoke the function with the event. And then for some indeterminate amount of time afterwards, it's kept warm and it's able to then very quickly respond to any subsequent requests. Now, cold starts, for the most part, in a fairly active application, they're the exception. They don't happen all that often. The big paradigm shift when you're looking at serverless is that it parallelizes and scales horizontally to levels that you could never obtain hosting on your own. So that whole idea of that cold start bringing up a instance of your Lambda function, that's just one instance. If you have more requests coming in, more things that are triggering that Lambda function, and that current instance, that warm instance is already busy, it's just going to spin up another one to handle it, an exact copy. And it'll just keep doing that to handle the load that your system is under. And then once all that traffic goes down, they all go away. And you're only being charged for what was actually running to handle those requests.
Okay, that's really cool. I like that.
You don't set up anything for scaling. The only limit you have to worry about is the maximum concurrency that your account is set to, which can be increased if you just, ask Amazon nicely. Like the amount of parallelism that you can do in these systems from just a brand new account is unprecedented if you go back 10 years.
Yeah, and it really solves some of the issues we've seen in our kind of, viral connected world, right? Of the social media hug of death when maybe a popular blog post hits the front page of Hacker News or Twitter or something, and it's some poor college professor's blog, and the entire thing is completely unresponsive for days. That's the opportunity where the Amazon protection or the Amazon Lambda scale up functionality would be able to horizontally scale and absorb that capacity. You don't have to think about it, and then if at the end of the day the blog post isn't as viral, it'll scale down automatically, and you're not charged for that. And you also don't have to think about it. I should note there are a number of options to mitigate cold starts for users who might be concerned about them. There's options to tell Amazon, like, keep a couple of warm copies of this function running, for example. And there's also a lot of things you can do in your code itself to sort of limit the impact. In a world of like a Node.js application, you can kind of expect a smaller than 1% of your invocations will be cold starts, and when it happens, you can expect somewhere between 50 to 100 milliseconds of additional latency, and that's reported, and there are metrics, and of course you can report on those and get an idea of what that is impacting for you specifically.
So it's not like you're spinning up a full like Rails app with like test suite and everything like that, where it takes 20 minutes. We're talking milliseconds here, so it shouldn't be that noticeable to an end user.
Yeah, and it's going to vary depending on the shape of your application, and the type of runtime and things like that. But yeah.
Just to give you a speed example, Tim. Let's say that I have an API gateway that's hooked up to a Lambda function for handling API requests. Now, that API gateway is always accessible, no matter what. Like, that's not a consideration. It's just always there. That's an Apache server or a Nginx server or whatever that you don't have to think about. Now, that Lambda function, we do Python development. So to give you an example, if I crank up the memory, which memory on Lambda functions is really a resource slider. You add memory, it means you get more CPU and more network I/O. They don't really do a good job of documenting what those values are, but that's how it works. So like if I have a gig of memory assigned to a Lambda function, and during its cold start, it's doing things like initializing the SDK for it to be able to talk to other AWS APIs, the cold start might be around the 300 to 400 millisecond mark. But then every single warm invocation after that is sub 10 milliseconds. It's ridiculously fast.
Yeah, it's just going to depend on your application, right? And, like everything in this industry, it's a sequence of trade-offs. If you require, real-time applications, you're probably not doing it over the public internet. However, if you're, if you can absorb a little bit of latency and the benefit of absorbing, a P99 time of, say, 400 or 500 milliseconds, and the rest of your invocations are all under 100, at the benefit of having near infinite horizontal scalability and no infrastructure to manage and no operating systems to patch and no firewall and networking and security concerns to worry about, that seems like a pretty good trade-off. But really, we're just scratching the surface, right? We're talking about the compute. And I think for most folks, what they upload to their Lambda function to actually run is almost the most boring part of the application, right? Like the idea of this world of serverless and this sort of concepts that it allows is it unlocks the ability to build what we call like an event-driven application, which allows you to model things that change in your system as events and then capture and share those with other aspects of your system. So if you've ever had to write like a web scraping application that would just like periodically poll a website for data, how fragile that can be and how limited your data fidelity is. If you can imagine putting that in a production app, it probably makes the hair on your neck stand up a little bit. However, in this world of serverless, everything can be event based. So, for example, if you want to share with someone who cares, that being another part of your application or your platform, you can push a message onto a message bus or a pub subsystem or the kind of latest and greatest product that Amazon has called Event Bridge, and you can have this structured event model that everyone understands the API contract between events, and then you can publish to a common bus where listeners, for example, you have an ETL job that has to fire after a certain process is complete. That can all be linked together inextricably in a way that previously required kind of some kind of crufty plumbing work, if that makes sense.
Yeah, you kind of triggered me when you said writing a web scraping app.
Yeah, it usually does trigger a few folks, but really, you can even take this to like the extreme, right? Like, so much of what we're doing in the serverless world is like intentionally trying to end our functions as early as we can. And let me give you an example of that. Let's say I am writing an application where a user signs up for my great website, right? Corey Quinn loves to do, Twitter for pets. So let's say I'm building Twitter for pets. And after you sign up for Twitter for pets, I need to validate that you're a real person. So I'm going to send you an email. Now, in the Rails app that you had described, you might try and do that in a callback, right? You may even have, say you get rescue or delayed job hooked up, but let's not even go there. Let's assume you're doing it in a callback. Say your email provider goes down, you're using, a third-party provider that's a little flaky. And when you trigger that user sign-up event, it fails because you can't send that email. Now, we know, in a modern application, we'd be using, a queue or a message bus or something like that to separate those two events. But with serverless, it's even easier, right? Because you can hook up a Lambda function to your database. Say you're using Dynamo, you can get an actual stream of data. So suddenly this process becomes the user clicks create an account. We're going to store their username and a hashed version of their password securely in Dynamo. And we're immediately going to acknowledge that result and send a message back to the front end, 200 or 201, okay, right? Record created. And what's going to happen is after Dynamo creates that record, stores in the database, it's going to call another one of your Lambda functions. And then that Lambda function itself can be responsible for queuing the message and sending the email and handling all sorts of those things that can happen in the background. So in the Rails example, asynchronous is not necessarily the default process, right? You usually start with like a callback, and from there you get burned, right, in an incident or an outage, and you're like, oh crap, I should really make this a background process. And then if you don't have that, you have to set that up. Not the end of the world, but that's the sort of the methodology. Now contrast that with like an event-driven serverless world. It's asynchronous by default. Like the entire stack and all of the collection and suite of products are meant for you to be able to, acknowledge your consumer as fast as possible and then schedule and handle work in the back end in a place where, the user isn't immediately waiting for that feedback. And that's really the capability you can unlock, is just that this event driven by default is just built into the entire ecosystem.
One thing that that we talked about a little bit earlier, and I'm just thinking through, like, the listeners who might be listening to this might be starting to get a little lost in the weeds. So I'm thinking of like a lot of times people will hear the term cloud computing and hear the term serverless and maybe, conflate the two. So I'm just, as kind of a quick abrupt topic change, I'm curious to hear what you guys see as the difference between like what is cloud computing and what is serverless.
To me, cloud computing is a really broad category because it can encompass all kinds of workloads. The most important thing is that you're not running your own infrastructure. You're using your provider's infrastructure and you're leaning into your provider's resources. Now, you might still be provisioning virtual machines, and you might be, running them like they were bare metal servers on in a traditional data center. You might be rolling Kubernetes or ECS and, running containers. Or you could be doing serverless compute, functions as a service, like Azure, GCP, AWS. They've all got options for all three of those categories. All of them do constitute cloud compute. The biggest piece of it is just that you are not running your own infrastructure, and it's running in your provider. Serverless is just one of those three categories. No, that's not even true. Like you can run containers in a serverless way. The idea there is that the abstraction is you're not running your own clusters. You have your image, and then you say run a container for me. AWS and Google both have great options for that.
If folks are looking for a metaphor, perhaps an easy, if not super high fidelity metaphor, would be the difference between renting a car and taking an Uber, right? You have the same concern about either, right? You don't really care about whether or not the oil is changed or whatever in the underlying vehicle. You're just trying to get from point A to point B. One of them has, the renting a car has a little bit more constraints around it, but a little bit more freedom too, versus an Uber. And they both kind of have their use cases. In the world of traditional cloud compute, a little bit more like renting your own car. You can sort of do whatever you want with it, and you give it back when you're done. The Uber is a little bit more pre-planned, and you sort of have to kind of do some setup work up front. But once you're in it, it's all hands off. Hopefully that resonates a little bit. But for folks that maybe haven't tried the cloud at all, right, or are familiar with the cloud in terms of what they read, in newspapers and see on TV, the serverless is just a sort of an evolution of cloud offerings. It's still a cloud service. It's still something where you're paying for the time to use effectively, and that's the same thing you kind of do with the cloud. You just don't care nearly as much about the ins and outs or the details. And at the same time, you also aren't necessarily on the hook for the traditional payment model of the cloud, which is like you pay, you turn it on, you pay for the month, and that's sort of, your bill kind of just climbs month over month and year over year, and versus a serverless, billing model, which is really just about paying for what you use. Pay for only what you use, never pay for idle, scale up to infinity when you need it, and scale down to 0 when you don't. And that's the core difference for folks that maybe don't have a ton of cloud experience. It's really more about the billing model, because as a user, you wouldn't really notice, if you're using an application that's written serverlessly, quote unquote, versus like a normal cloud application. If they're all routing to the same, data center, perhaps the US East one in the version of AWS, you're probably not going to notice a difference.
Maybe one other layer on top of that, AJ, is the which people might be able to relate to, is you're losing the system administration aspects of what you're doing.
Yeah, for sure.
As you move into this model, like, you still have system configuration. It's much different, and it's almost entirely YAML. But like, you no longer are concerned with what are traditional system administrator tasks. Like, those go away in this model.
Yep.
Nice. So I think maybe I should start here. I want to kind of do like a pros and cons to see if that also helps, clear things up. So I think starting with the pros, we've talked already a lot about how you're paying for what you're using. And so that can really help shrink down your bill, especially if you have kind of spiky types of traffic where you're mostly idle and no one's using your app for a long period of time. Then all of a sudden you get a big boost. It's like you can scale up, handle that traffic, and scale back down. Are there any other kind of noteworthy positive things around serverless computing that you often go to when explaining this to people?
I would say team independence is a really big one. This model allows teams to take on operations for what they're building and deploying far more easily, because a lot of that underlying responsibility, that's shifted off to your cloud provider. It's shifted off to AWS. I'm not concerned with the stability of the availability zones within the region that I'm using. I'm not concerned with the server racks where my code might be running or my services might be running. Like, there's a huge amount of burden that's shifted to them in the shared responsibility model. And a team doesn't have to rely on other sort of like platform or infrastructure teams within a company in order to actually build, deploy, and manage their software.
Yeah. To expand on that even a bit further, so organizational flexibility, independence of teams. You can also, the ability to sort of standardize on public API contracts, right? Instead of necessarily having to talk to each team about, how are we going to communicate? You can kind of have an agreement. Okay, like we'll listen for a message on an event bus, or we'll listen for like a message set onto an SQS queue, and you can sort of have a little bit more of a fundamental understanding and a managed experience that way versus necessarily setting that all up yourself. But there's so much more, right? Like on the pros side in the serverless world, you can experiment so much more freely, and you don't necessarily pay anything. Amazon has a very generous free tier for their serverless applications, and that's why I encourage folks who are new to the cloud, students, young folks especially, to sign up, and try and build just with the serverless tool set, because for the most part, you're never going to get a credit card bill for those services. But that extends also to things like development environments. If you remember, Tim, back in the day of your server under your desk, if you were lucky, maybe you had a development environment, right? Or like in the early days of a startup, you may have like a dev and a prod environment. But someone messes up your dev environment or your staging environment, and you're kind of all stuck until you fix it. With serverless, you can kind of deploy infinite copies of your stack, and it comes at no cost because you're not paying for the infrastructure, you're paying for when it's used. So if you wanted to deploy 4 or 5 copies of your application and do some, say some exotic A, B, C, D, et cetera, testing, you can do that. And at the end of the day, your bill is going to be the same. So if you have that sort of a use case where you're rapidly experimenting and prototyping and iterating, I think that serverless makes a lot of sense in that phase. And then as you grow, you can look at your load and say, okay, from 9 to 5 Central Time, we have sustained load. We can move that into some other cloud technology like Fargate and get a little bit more of a discount on the bill overall. And I think that's really where the bulk of the pros kind of fall under, is this flexibility and this sort of freedom, while knowing that you're still kind of in this pay per use model without having to really worry about the costs for the vast majority of prototypes and experiments.
And you know what? One more thing to add on to that, Tim. because we didn't touch on it too much. We hinted at it. Like we went through a whole bunch of examples of like, things you could do as a serverless application with analogies to how you would build it elsewhere. But in every single one of those, we mentioned a Lambda function. And it does, merit being said that every one of those examples we just walked you through, you actually could do it without a single Lambda function in the mix.
Yeah.
No code.
Which that'd be pretty sweet for what I'm thinking through like applications that I maintain, like with our company, we, have a lot of different apps that we have with a lot of different usage patterns. And, we've always been just, you stick with what especially when you're having to get stuff done as quick as you can. You kind of go to your tools that you have. So learning about this serverless thing is and learn a serverless thing like it's a new thing. I already feel like
it's still new. It's still that's fair. It's new. Yeah.
But, I think one, maybe what would help me as well is kind of evaluating the cons, because you kind of hinted at a couple of them just even through saying like if you have an application with sustained usage, I would imagine like, the pricing makes sense if you're able to fire it off and shut it off in a second and you're doing that, and you're able to kind of mitigate the cost that way. But if you have something where it's like sustained load, I'm sure the pricing works out that you'd be better off hosting it where it's just more of a sustained connections. But I don't want to put words in your mouth. I mean, what do you guys see as some of the downsides?
You're not wrong. The pricing model in serverless is really about invocations. Like how many events are happening, whether that's users making API calls or actions off of that in your backend, you like triggering other things. Like everything comes down to the number of requests that are being responded to. And the pricing is very deterministic. Like it's actually very easy to know exactly what you get charged on a like per million requests basis. But if you have something that, you're doing millions and millions of transactions on, then that is a consideration when you start getting to that scale where you have to take into account, okay, what is invoking these functions, these services the most? And is there a way to mitigate that and batch it? Because that's where,
and some of that.
Yeah, go ahead, AJ.
Oh, sorry.
No, go take it.
Some of that might even be irrelevant, right? Like we were discussing the polar or the web scraper that you may have written, right? Or some other way where you're exfiltrating data, or you have to constantly check to see if something is alive, right? Any of those can be kind of rewritten in a serverless way where previously what was say like hours and hours of CPU time is cut down to only a few milliseconds. So negating that, there's other cons I think we should probably cover as well. But I do want to make a point. Total cost of ownership is still, doesn't just encompass the AWS bill you have, right? Like it's going to matter for the people you're hiring to bring on and work on these systems, and potentially brain drain when folks turn over or decide to move on to other opportunities. The cost of rehiring and reskilling for that role. So the more you can kind of offload and pay a predictable known price to a cloud vendor with contracts and SLAs, that might be something very worthwhile to consider for your business. So it's so much more than just what you're paying for. Your cloud bill might go up, but other things will free up your team to go and focus on other business outcomes. And that's kind of the idea. And the buzzword in the serverless space is undifferentiated heavy lifting. And I think that's really comes from the business side of the house in corporate speak, but really, unpack that. It means everything that your company does that doesn't make it different from another company. The idea is to offload all of those things to some other vendor, as much as you can. And you can see that all over, right? Payroll, voice over IP software, that sort of thing. You're not kind of building your own telephone systems. And that's kind of the drive behind serverless is they look around and see, okay, everyone's sort of deploying the same type of application. Maybe we can build that and offer it as a service. So that's kind of part of the pros and cons there. There's another con a lot of people talk about that I want to touch on, and that's vendor lock-in.
Is it though?
Vendor. Oh, it's definitely a concern people bring up.
I feel like I don't think it's
to neglect it.
I'm of the camp that it's a feature and not a defect. But yeah, I'm going to let AJ speak here.
Yeah. So in my consulting days, what I would always advise folks is pick one cloud and use everything about it. I don't think for the vast majority of use cases, it's advantageous to shape all of your decision making with the idea that I'm going to want to move this to a different cloud. I think that will hamstring your engineering talent in a way that will limit your ability to get things done in a timely manner. So my number one recommendation for everyone listening is pick one cloud and just use it, exploit it entirely as much as you can. Now, with that caveat out of the way, some of the concerns folks have around vendor lock-in is that with a container-based application or something that runs close to bare metal, I can lease a vaguely Linux-based machine from any provider. Gosh, you could even go to Oracle if you really wanted to.
Why?
I think Corey's ears are burning right now.
It's a little Corey subtweet. But you could go anywhere and deploy that application, and that's sort of true. But that limits your ability to sort of use the advantages that the cloud gives you, right? Like if you're gonna, if your cloud migration strategy is to just take the computers that you have in your basement, image them, and then upload them, you're not going to get a lot of the economies of scale that you can get from an Amazon or an Azure or a GCP. Versus if you look at that and say like, okay, we're going to embrace this technology wise, what can we get out of it? That's when I think like the vendor lock-in story starts to disappear. And the other thing I always point out is, vendor lock-in, I don't think really occurs so much at the application level, because we're at a point now where we have so many orchestration tools that make it relatively easy to spin up new copies of your app horizontally, right? So if you have a high load, it's not necessarily that challenging to bring up another container or even another EC2 instance. Heck, I can do it from my command line right here. However, that lock-in really lives at that data level, right? Where your actual data lives. Because that's what you can't, you can pick up and move and flee your cloud provider with your applications, but getting that data out of Amazon is notoriously costly. So, and I'm just not seeing people rush to run their own distributed data stores. Folks are using RDS, or running with Amazon's managed MySQL or Postgres databases, right? They're not necessarily, running their own bare metal machines and then deploying databases on top of that. And I think that's where that lock-in lives, serverless or not, right? Where your data is, because that's the expensive part to leave with.
Let's bring up one other con though that you and I did mention, which is actually the con. It is the big thing, and that's the hello world problem.
Oh yeah,
and. So, Tim, like, we've got you all starry-eyed now. You're like me back in 2018, where you're all starry-eyed, like, wow, this sounds amazing. You're probably now wondering, like, well, how do I get started? And this is where, like, AWS has a fantastic developer relations group, and there are so many resources out there for you to jump onto, especially with the community. But they lack a, guide, which is, here's how to start building applications in serverless. Like here's like going through building a real world example, not just, like here's a Lambda function, have the Lambda function print hello world, but like having that Lambda function do meaningful business logic, having that Lambda function hooked up to event sources, utilizing data stores on the back end, serving content out through a CDN. Like Amazon doesn't have a good hello world story for serverless, or at least I have not seen it.
Yeah, I broadly agree. There's also not really one opinion that's unified on how it should look. I think that's a huge opportunity for Microsoft and Google. So if you're listening, folks, that's what I would take. The other aspect there is as we mentioned, serverless isn't one technology or one application. It's a collection of managed services. And how do you get started with those? And how do you even know which one to pick? So what really I think I've seen for folks on their serverless journey is they pick up something like Forrest Brazil's A Cloud Resume Challenge, which is great. I plug that, highly recommend it.
Same.
As a way to sort of learn the different services that clouds provide, and how you can kind of use them together. Once you have that understanding, the idea of serverless is sort of laid bare and apparent. And it's like, oh, I can connect this managed service to that managed service, and I can transform the JSON or the input with a little Lambda function here or there. And then suddenly you're kind of off to the races.
And all those examples in the community start to click as well, and you know how to implement those examples and those resources.
Yeah, absolutely. And that's where you start to unlock some of those other kind of higher order benefits you get from serverless, like I was describing with DynamoDB streams previously, where you can sort of return to the user as quickly as you can, and then you can also publish this message to the rest of your application, so you have very clean domain boundaries between services. But as far as organizations looking to adopt it, the hardest thing is that cloud competency, right? Like, so, and that's just that, like I said, that's not really a consequence of serverless. That's just the cloud in general. And for Amazon specifically, learning how to deploy a serverless application to production, you have to have an understanding of, not only the underlying services you're linking together, like, API gateway or Lambda or Dynamo, but also things that govern it, like identity and access management, or IAM. And these are not trivial things to learn, and they can be tough to get right. And I think that's where there's a lot of opportunity for education. But I think that's the biggest con right now in the serverless space is being able to sort of have an understanding of how to build the things you're trying to build. And I think they're to Amazon's credit, we shouldn't just ding them. They do have the well-architected framework that they've created, and other organizations like the Lego Group are sort of famed for having an engineering culture that has this, like, here's what we think a well-architected serverless application looks like, and here's a checklist you can kind of go through. And they've made that public. So those are all great resources that I'd suggest. But really, the hard part about getting started is literally developing that cloud competency and learning how to put these things together in a way that is coherent and correct and solves the problem for your business.
I would not pitch the well-architected framework as something for getting started. That's really something for after you develop the competencies and after you're starting working on applications and serverless, then you apply the well-architected framework to it. It's pretty deep. It goes really deep on implementation details.
Yeah, I can't ding them for their lack of technical rigor. I meant that in terms of there's a way that you can sort of they're working on a tool set that developers can use to kind of verify and kind of check their math in terms of does this work with that. But there's still, I think there's a number of good community driven articles and blog posts and walkthroughs and even like books that people have published that I think are pretty useful. But there's not necessarily like a one voice from the cloud provider of like, here is how you build serverless applications on Google or on Amazon. I think that is still new. And again, it's a developing world. I think the capabilities, the growth of the capabilities is still pretty recent. And I think the educational stuff is going to come with time.
Yeah, I think the thing I've taken away from serverless, and I mean, my general approach to technology is to be not on the bleeding edge, because I've been burned so many times. Like, I've been doing this long enough where I just know if I adopt a technology too soon, then I know that that's going to go away in 4 days.
Yeah, Tim, so, that's why they call it the bleeding edge. It makes you bleed.
I don't know. It kind of sounds like he's been building on Google.
All right.
I'm more referring to my days with building like DHTML websites and working with like ActiveX extensions and things like that, where it's like, yeah, that went nowhere, and I'm glad that I spent all that time learning that stuff. But it seems like serverless isn't going anywhere. The thing that's different about serverless than building a traditional web app is just understanding the mental model of how all the pieces fit together, and those seem to be like. Correct me if I'm wrong, but we talked heavily about AWS, Amazon Web Services, within the context of serverless here, but you also alluded to the Google Cloud to Google Cloud and to Microsoft Azure, and I mean I dogged on Oracle, but there's all kinds of different. I don't want anyone at Oracle mad at me.
Even Mongo's got their own stuff now, and Cloudflare has their own stuff.
OpenWhisk.
Yeah.
There's a lot. You're right. You're totally right, Tim. I think if you're looking for that, that first little project or that kind of first attempt or first thing to try, my recommendation for everybody who's like, okay, I like this, but if I just deploy Hello World, it's going nowhere, right? It's just going to sit in my cloud account, and thankfully it won't cost you any money, but it's just going to sit out there. However, what I'd really recommend, if you have these traditional applications and say a customer comes to you and said, we love this app you built, Tim, and we love what it does for us. We just really need it to call this API endpoint when something happens, or we really need you to create, this one little endpoint that we can hit to, shuttle a little bit of ETL data over to you to make this report, complete, and those types of things. When you have these requests that don't quite fit the domain model, and as a developer, you maybe get that little bit of of an itch where you're like, oh, I don't know if I want to put this in this app. It doesn't really belong here, but it's got to go somewhere. I think that like glue code is like the perfect wedge opportunity to try something out for serverless, because it really, if you need that one endpoint with maybe a little bit of JSON stored somewhere, and then the ability to kind of do something maybe asynchronously, or, just expose something for a customer to hit every so often, serverless fits a really great use case there. And that's where you can really, try some of these things out in a way that you actually are going to care about the outcome and kind of explore and be engaged in that outcome. Number one recommendation is find those little spots for those glue code applications where it doesn't quite fit the rest of your app, but it has to go somewhere.
Yeah, I'm going to echo that, because that's really how I got started here at Jamf, and a couple of others did too, because that work that I was going to do in Flask and then switch to Lambda, that was really about extracting business logic out of our monolithic automation. And we built it in Lambda on the side instead and just plugged into it. So like it's a little bit of like the Strangler pattern, I guess, where we
would start echo that.
Yeah, where we were replacing parts of our original automation with serverless that just ran on the side. And it led to all sorts of opportunities for us internally.
Nice. One final question for you guys. You've already given a lot of different resources for people getting into this space, but one question that I've been asking as part of this series is, I'm sure because of how passionate you guys are about this, you know who some of the influencers are in this space and people that you follow on either social media or newsletters or, what have you. Are there any people that come top of mind to you that you prefer to follow to kind of stay afloat of what's going on in the serverless world?
Yeah, Eric Johnson, James Beswick. They're both developer advocates at AWS. You can follow them on Twitter. James does a lot of the blog content. Eric is a lead serverless developer advocate. They always are posting the latest updates to what's going on in AWS. They reshare things from other members of their teams. They're fantastic sources.
Yain Chui is the Burning Monk on Twitter, and you can go to theburningmonk.com. Check him out. I think he's got a lot of really good articles and blog posts, and has just a good reputation in the industry. I also highly recommend Jeremy Daly. Publishes Off by None, which is a weekly newsletter about serverless things.
I'm also going to plug Emily Freeman, who now heads community engagement at AWS.
Yeah, so we've already plugged Forrest Brazil. He's the new head of content at Google, but definitely check out his website, his newsletter, and the Cloud Resume Challenge. I think is a really great way to get introduced to the cloud. Yeah, absolutely.
Well, excellent. I mean, I've got a list of people now that I can go follow. I'm sure that lots of people, if you're interested, I think that's where I've found asking who the influencers are kind of helps you kind of shape where you want to go. But speaking of influencers, AJ, Bryson, you guys have given a lot of information here today, and I would love for you to give a shout out for whatever you'd like to. Plug yourselves, plug Serverless Minnesota, like whatever you think would be appropriate at this point.
Well, I don't have a SoundCloud, but you can find me on Twitter.
Yeah, you can also follow me on Twitter, twitter.com/ASTUYVE. I know my last name is a curse, not a blessing. But also check out Serverless MN. We do have a lot of content uploaded at our YouTube channel from different talks. Again, it's hard to get folks to kind of get excited about a Zoom meetup, but there are a number of them that you should check out, including folks that Bryson already mentioned, like Eric Johnson did a great one. So come and check it out. Check us out. Thanks so much, man.
Thank you.
Yeah, thank you guys for coming on. This was super, super helpful for me, at least, and I'm sure a lot of people are going to take stuff away. So thank you for sharing your expertise with us today.
Yeah, it's fun.
Yeah, you bet. Now's the time. Try it out. Try out serverless. Just give it a shot.
A big thanks to Bryson and AJ for joining Tim on the podcast today. You can connect with any of these gentlemen on Twitter. Show notes for this episode can be found at constantvariables.co. You can get in touch with the show by emailing hello@constantvariables.co, or you can find us on Twitter at CV_podcast. Today's episode was produced by Jenny Karkowski and edited by the melodic Jordan Doust. This episode was brought to you by the Jed Mahonis Group. Find us at jmg.mn or connect with us on LinkedIn.